Hello, we get to continue from our chapter on polynomials, and last section we talked about using the FOIL method to multiply our polynomials, and now we're going to continue looking at special products within our polynomials. First, let's review this FOIL method. We've got x squared plus x times, or x plus y times x plus y. And remember, we use the first terms, gives me x squared, the outside terms xy, plus the inside terms xy gives me 2xy. And the last terms, y times y gives me y squared. In this one, we have an x minus y. So if we multiply the first terms, x squared, the outside term is negative xy, and the inside terms gives me positive xy. So what happens with that? That just cancels out to be 0. And then all we're left with is y times negative y gives me minus y squared. Then for the next one here, we've got a plus 5, a minus 5, same thing. Because one is a plus and one is a minus, the outside and the inside terms are actually going to cancel out. So then we have 5 times negative 5 gives me negative 25. So a squared minus 25. Now, if I have both our subtraction problems, then my first term's a squared. The outside term is minus 5a. Inside term is minus 5a. So when I combine those two, I get minus 10a. And then negative 5 times negative 5 gives me a plus 25. Notice there is a bit of a pattern here when you have the first term is a plus and the second one is a minus, but other than that, they're the same. Then take a look at these. Is the first term and the last term perfect squares of those. All right, we will continue talking about that though as we go. Okay, let's take a look here. If we use the FOIL method to multiply this, 2x times 2x gives me 4x squared, right? But here I have outside terms are 2x times 3a, and then this is minus 2x times 3a. That cancels out, doesn't it? Becomes 0. And then now I have minus 3a times plus 3a. That gives me minus 9a squared. So my final answer now is 4x squared minus 9a squared. These special products, we can see a pattern in them. Recognizing the patterns in special binomial products can save you some time. And I pointed out some of those patterns earlier, and we will continue to see some more of them. All right, the first special product is the square of a sum. The square of a sum, okay, if it's a plus b, and I'm going to square that, okay, then it's the first term squared, the two terms multiplied together times 2, and then that gives us 2ab. Then the last term squared gives me b squared. Okay, now here's a diagram of this. A plus b, right here, times a plus b. I have first a squared plus 2ab, those are the inside and outside terms combined together, and then b squared, the last. First, outer, inner, last. FOIL. Now, try this one, okay? X plus 2 squared. So it's the first term squared, x squared. The outside and inside terms, it would be 2x. 2 of them, right? So 2 times x times 2. So basically this middle term here is going to be 2 times x times 2. And then the last term squared, plus 2 squared, which is 4. So we have x squared plus 4x plus 2 squared, which is 4. And there's my final answer. Let's say we have 3x plus 4, and we're going to square that. So first you take the first term, 3x, and you square that. Then you take 2 times the product of these two terms. 2 times 3x times 4. There we have it, 2 times 3x times 4. And then the last term, 4 squared. And that gives me 9x squared. 2 times 3 times 4 gives me 24x. And then 4 squared, 16. And here is my final product. These special products, the next pattern we see, okay, the square of a difference is going to give us the first term squared, and then 2 times a times b, but you're going to subtract it this time. And then the last term, because a negative times a negative gives me a positive. So negative times negative is going to be positive b squared. All right, now let's say we have y minus 3, the quantity squared. If we take the first term, y squared, and then 2 times y times negative 3. Okay, that's going to give me negative 2y3, and then negative 3 squared gives me plus, right, 3 squared. So y squared, 2 times 3 is 6y, plus 9. And there's my final answer on this one. Okay, all right, now let's take this and square it. So my first term, 2x, I'm going to square that. Okay, and then 2 times 2x times 5y, but minus, negative, right? So negative 2x, negative 2 times 2x times 5y. And then my last term, okay, negative 5y squared, so that becomes positive, right? Because negative times negative becomes positive, and this is 5y squared. So I simplify all this. 2 squared is 4, and then x squared, minus 2 times 5 gives me 20xy right here, plus 5 squared is 25y squared. And then this is my final answer from here, this quantity squared. Now, remember, these are differences, okay? A quantity that's the difference of a quantity squared, and it will give me these products. 2 binomial expressions, one indicating the sum of 2 terms, the other indicating the difference of the same terms, are called conjugates. Okay, so remember, conjugates. Okay, in other words, I have 2 terms the same. Okay, one is the sum of it, and the other one is the difference. They're opposite, basically. I'm adding and I'm subtracting the same set of terms. Okay, those are called conjugates. So for the example here, okay, a plus b, and then here I have a minus b. These are called conjugates because one is adding a and b, and this one is subtracting a and b. They're opposites, so they're called conjugates. So my first term is a squared. And then outer terms are negative ab right here. The inner terms are plus ab right here. And the last terms, b, positive b times negative b, gives me minus b squared. Then I'm going to combine negative ab plus ab, cancels out, right? So I have a squared minus b squared, and that is what I end up with here. The product of conjugates, okay, the opposites here, is the difference of 2 squares. So if this is, these two are conjugates, okay, they're opposite. This is plus, this is minus. then all I have to do is actually, it's just the first term squared minus the second term squared. All right, let's take a look at another example here. Let's say we have x minus 4 times x plus 4. So this is basically the first term squared, x squared, and then the last term squared, 4 squared, okay? And it's the difference between those two. So this is x squared minus 16. Let's say we have 3x plus 7y times 3x minus 7y. Okay, these are conjugates again, right? And these conjugates, you take the first term, 3x squared, and that's going to give me, and then I'm going to have minus 7y squared. So I simplify that, and that just becomes 9x squared minus 49y squared. Okay, so it's the first term squared minus the last term squared. Okay, the square of a sum. So if I have a plus b squared equals a squared plus 2ab plus b squared. Square of a difference, okay, a minus b squared. That's going to be a squared minus 2ab plus b squared. The product of conjugates, okay, a plus b times a minus b is just the difference of the two squares, a squared minus b squared.